Hey everyone, this is Paul again with another exclusive demo video for all of our SQL Insider friends. This one's coming to you live from the Hard Rock Hotel in Orlando, where we're currently on vacation with the kids. But I wanted to make sure that we got our bi-weekly insider tips and tricks out to you. So for this demo, what I thought I'd do is do one of the demos from one of my sessions at SQL Connections that I did last week. What this demo is going to do is show you a few undocumented DBCC commands and also show you some of the information that's stored in the boot page of the database, page 9 of file 1 always, and when it actually gets changed. So what I'm going to do first of all is create a database to play around with. And the command that you can use, undocumented, unsupported, but very safe to use, the command you can use to look in the boot page is called DBCCLogInfo. Now, just like a lot of the DBCC commands, you can't actually get any output to your current connection unless you turn on that trace flag 3604. Just the same as for DBCC page. So we turn on this trace flag, and we see a whole bunch of stuff that's stored in the boot page. So for instance, we get our database ID, we get, let's see what else is interesting, obviously the name of the database, we get the database creation version and current version. So these are the physical version numbers of the database. So you'll see that I'm running SQL Server 2005, and the version that's supported by that is 655. If I was running 2005, I would be running 611, and if I was running, or maybe 612 if I turned on bar decimal in SP2 of 2005, and if I was running on 2000, it would be 539 if I remember correctly. So remember that physical version number is nothing to do with the compatibility level of the database. If I have a database of physical version number 655, I cannot restore it back to a 2005 server, because 2005 servers only understand versions 611 or 612. SQL Server is not up-level compatible. So what else have we got here? We've got the creation date, which is just about now, as you can see. We've got a whole bunch of log sequence numbers around checkpoints, around backups and so on. We've also got this counter, the number of times that the transaction log has been rebuilt since the database was created. This is now tracked in the database from 2005 onwards, and is a way for product support to tell whether you've done something that could compromise the integrity of the database. The reason that was done is because product support and the development team at the time were finding that people would call in and say, I've got corruption, and would essentially not tell the truth. And they'd done something like using the old DBCC rebuild log command and caused corruption, and then asked the product support team to try and help them. This here, a flag number of 2 means that the database is marked as pure. So on 2000 and before, it was possible to import invalid data into SQL Server. 2005 fixed all those holes, and the recommendation was when you upgraded to 2005 that you ran DBCC with data purity, CHECKDB with data purity, and that would check whether you had any invalid data in your database. If it didn't find anything, it would set this bit in the boot page, and it's an irrevocable setting. Once it's set, it can't be unset. And that says that the database is now pure, doesn't have any bad data in, and those data purity checks will be run every single time you run CHECKDB by default. This guy is the time that CHECKDB last ran without finding any particular problems. All right, we're going to go and change that in a second and show you. And there's a whole bunch more log sequence numbers and so on, all the way down. Now there's one other very interesting thing I want to show you, and it's down here. Here, look at this. This is here from 2008 onwards. It is the time that you last booted the server in single user mode, as in i.e. with -m, and then connected up to the server using the dedicated admin connection and modified a system table. Okay, sometimes you might have to do that as a way of fixing corruption if you want to keep the database running before you have to do the export-import into a new database. But from 2008 onwards, this is now tracked. Product support can see this, and if you've made a system catalog update directly, okay, then you might find that they'll say you're not supported. So several times I've blogged about how to do this as a kind of last-ditch effort of fixing system table corruptions, but now be aware that they're going to track it. Okay. All right, let's actually go and do something that we can see some of these numbers changing. So first off, let's have a look at the last known good time. Currently it's set to nothing. If I go run a CHECKDB, go back and look at our DB info, last known good is now set to the time that we just ran. Okay. So this is what gets printed out when the system starts up or you shut down and restart a database. So don't get confused by those messages that get printed out saying CHECKDB last ran at this time. It doesn't mean that when the database is starting up, CHECKDB is running automatically. There is nothing in SQL Server that will automatically run a CHECKDB. This is simply just reporting this field from the boot page in the database. Another command that you may have seen if you read my blog is DBCCLogInfo. It's the only way to have a look at the virtual log files that are inside the transaction log. So what this is telling us is file ID 2, because your log file is always number 2, the size of the virtual log file, the offset in the transaction log of that particular virtual log file. Notice that the first one starts at offset 8K. That's because every log file has a file header page. The sequence number of the virtual log file, this is to do with how Crash Recovery knows where to look for the next virtual log file. Status of 2 means it's an active virtual log file. Status of 0 means it's inactive. Status of 1 used to mean something, nobody remembers what it used to mean. I even asked the guy that wrote the current transaction log implementation, a guy called Peter Byrne on the storage engine team, and even he can't remember what that means, so nobody knows. 64, so these are the parity bits, and they flip between 64 and 128 every time the VLF is used or reused. And this kind of plays into how the Crash Recovery system knows where to finish Crash Recovery. If you don't know what I'm talking about in terms of all this transaction log stuff, go over to my TechNet magazine blog category and look down for around February 2009. I wrote an article about transaction log, login and recovery, recovery models, and how all that stuff works, and it's all explained in there. So if we go and add a bunch more virtual log files, I'm going to grow the database. We're going to grow by 200 megabytes, and the formula that's used by the log management system says if you grow over 64 meg but less than a gigabyte, you get 8 new VLFs. So we grow by 200 meg, and we should find, if we run DBCCLogInfo again, that we have 10 VLFs now, because we had 2 before. Yeah, we have 10 VLFs now, and each one of them is 1/8 of 200 meg, which is roughly 25 meg each. So that's DBCCLogInfo. Again, go look on my blog, and there's a bunch of information about using DBCCLogInfo there. Kimberly also has a bunch of good blog posts about using these commands and getting your transaction log back under control. If you go to Google or Bing and search for Kimberly 8 Steps, her blog post will be the first one that comes up in either search engine. So how about now forcing a log rebuild? What I'm going to do is go into that database I just created, create a table, create a transaction, insert a record, and then do a checkpoint. So that's going to force the data page that has this record on it to disk. Now in another window, unfortunately, we're going to crash SQL Server. So SQL Server is shut down. Unfortunately, while SQL Server is shut down, what's going to happen is the log file here for that database unfortunately gets trashed by the I/O subsystem. Now what I'm going to do is fire up SQL Server again. We go back into our other window. Try to use my database. I get the disconnection message first of all, of course. Try to use the database, and now I get this message saying database cannot be opened due to inaccessible files, blah 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 blah. If we went to the error log, we would see that it wasn't able to open the log file. So one way to recover from this, if you don't have a backup that you can restore from, if you don't have a redundant copy of the database you can fail over to, is of course to use emergency mode and force the transaction log to be rebuilt. So I'm going to go ahead and do that. You have to be in emergency mode and in single user mode, then run CHECKDB with repair allow data loss, and that's going to rebuild the log for us. So it goes ahead and rebuilds the log, and look at this message we get back. The log for database, new database has been rebuilt, transactional consistency has been lost, the restore chain has been broken, blah 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 blah. Basically saying you've just messed with your database in a big way. Now if this was an OLTP database with lots and lots of concurrent transactions, all kinds of things going on, we would have seen a whole bunch of corruption messages there from transactions that hadn't yet rolled back, and CHECKDB would have fixed them all. But it did rebuild our transaction log. What about in DBCC DB info? What does that now say? if we go down, we'll see that the last known good wasn't updated. But if we go down and we see the, where is it? Rebuild logs, here we go. Rebuild logs is now set to 1, that was set to 0. So that is now tracked forever that we forced a log rebuild to happen. So that's using DBCCLogInfo. Now here's a script that uses a bunch of these different commands, and this is a script I give out as part of our server health audits, and it basically gives me back a whole bunch of information about databases, the transaction log, the number of log files, the number of virtual log files, and so on. But I'm going to package that up in the zip file that has the demo scripts for this demo in, and I'm going to give it out to all of you. So for instance, if we look down at all the code, I want to skip. You can see that it's using DBCCLogInfo, it's using DBCCDBinfo, okay, and it gives back a whole bunch of information. So if we go and run it, I'll run the entire script. We can see that for all of the databases on my server, it tells me the names, tells me the recovery models, the log size, the log percent used, the log file count, the virtual log file count. So this one here is pretty much out of control. The number of log rebuilds, we should see there's one that I just did that's been rebuilt. Right? And notice that the VLF count there is 2. I had increased the size of that log file to 200 meg, and it did have 10 VLFs, but when I rebuilt it, it got put back to what it was originally. Right. But you can see this is a very useful script for you guys to run and get a pretty neat picture of what's going on your server in terms of all your transaction logs and how healthy they are. Anyway, that's just a quick demo. Again, exclusive demo for all of our insiders. Thank you very much for being insiders. We love giving you out lots of cool information. And now I think I'm going to head out to the pool. So until next time, thanks for listening, and bye-bye.